Welcome back to Ms. Burkhart's math class. Remember to have your notes with you and something to write with so you can take notes as you watch. Remember, push pause so you can catch up with your notes as you're watching the video. You can always rewind, rewatch any parts of the video to make sure you really understand the concept. So today we are going to look at Standard 6.3a, identifying and representing integers. Specifically, today we're going to talk about, you're going to learn what is an integer and where are they on the number line. And also we'll talk about what are some real life examples of integers. So let's get started.
So what is an integer? Well, the definition is that it's all of the whole numbers and their opposites. So whole numbers, what are those? That's 0, 1, 2, 3, 4, and on and on and on. All the numbers that you've been working with since kindergarten. So it's those numbers and it's their opposites. So in other words, what's the opposite of positive 1? Well, that would be negative 1. So the opposite of having $1 would be losing $1 or owing $1. And then positive 2, and then the opposite of that, which would be, of course, negative 2, having $2 or losing $2 or owing $2. Positive 3 and negative 3, positive 4 and negative 4, and on and on and on. So all of these are considered the set of integers. Now, if we were plotting these on the number line, this part of the number line, 0, 1, 2, 3, 4, 5, you've worked with that part of the number line, again, since kindergarten. So that's nothing new. But over here, we plot the negative integers. So here we have positive 1, the opposite of positive 1, which would be negative 1. Notice they're both on the opposite side of 0. 0 is essentially the neutral, it's the middle ground. It is neither positive nor negative. 0 is neither positive nor negative. So then we have positive 2. What's the opposite of that on the opposite side of 0, which would be negative 2. Notice it is also 2 spaces away from 0, just like positive 2 is. And we have 3. What do you think's next? Yep, negative 3, positive 4, and then the opposite of that, which would be negative 4. Again, 4 spaces away from 0, but on the left side. And on and on and on. So all of the positive numbers are on the right side of 0 that you've dealt with since elementary school. And then all the negative integers are on the left side of 0. So where else can you see negative numbers? Well, I figured all of you liked and have mentioned YouTube. And you know right here on the bottom of the video where it has the thumbs up or the thumbs down, the likes or the dislikes. Those are integers. If you think of the thumbs up, those are the number of likes, and that's a positive integer. So this case, the 151K, 151,000, that's a positive integer, right? And likewise, the thumbs down, the negative, the dislikes, that represents a negative integer. So that would be negative 853. So you see integers and they're represented all over the place. They may not necessarily have the negative sign, like here it was thumbs down or dislikes, but that's how we represent, another way of saying negative 853. So let's do some more. What we're going to do now is practice locating and identifying where the numbers are, where the integers are on a number line, and how I can also represent them with our counters, because we will be using these as we move into adding and subtracting integers as well. So, as I said before, 0 is neutral. It's right in the middle. Think of it as 0 doesn't take sides. It's not on the positive side, it's not on the negative side. It is right in the middle. It doesn't take sides. So 0 is neutral. It is not positive, it is not negative. And our positives are on the right side, and our negatives are on the left. So let's just practice some. So let's say we're going to start with, let's just start with positive 2. And if I'm going to figure out where is positive 2 on my number line, I know it's positive, so it's got to be on the right side of the 0. And here's 1, 2. So I'm going to put a point right here, and I'm going to move my 2 to the second spot. Now, how would I show that with my yellow? We're going to represent our yellow counters are going to be positive. Our red ones are going to be negative. So here would be, of course, two positives. Again, I know you know this. Now let's do the opposite of positive 2. What's the opposite of having $2? That would be owing $2 or losing $2. So that would be negative 2. The opposite of positives are negative. And so where would this be on our number line? Well, we know negatives are to the left of 0. They're on the other side of 0. So here's one space away from 0, so that's negative 1, and then there's negative 2. So this is 2 spaces to the left of 0, and that's our negative 2. All right. How would I show two negatives with the counters? Just like this. Here's one negative and two negatives. Pretty straightforward. Let's try another one. What about positive 5? So it's like having $5, or if you've played football or no football, that would be moving 5 yards, moving ahead 5 yards. So where is that going to be? Well, it's positive, so it's going to be on the right side of 0, and it's going to be 5 spaces away from 0, so it's 1, 2, 3, 4, 5. So here is where positive 5 will be. So we'll just move that over to positive 5. Now, what's the opposite of positive 5? Negative 5, right. So it's like saying I owe $5. Or, back to our football analogy, that would be being pushed back 5 yards. You lost 5 yards, a 5-yard loss. All right, so now where's that going to be? Since it's negative, what side's it on of 0? It is to the left of 0. How many spaces? It's 5. So here's negative 1, negative 2, negative 3, negative 4. Negative 5 is right here, 5 spaces to the left of 0. And so let's just move our number over here. So how would negative 5 look with our counters? Well, we already have 2, so let's just add a few more. Negative 3, negative 4. I'm just going to move these over. And negative 5. And of course, positive 5, here's positive 3, positive 4, and positive 5 with our counters.
Now we're going to identify if a number is or is not an integer, because yes, there are some numbers that are not considered an integer. So let's just really quick review what we just went over, which was a definition of an integer, which was all of the whole numbers that you've worked on since kindergarten, 0, 1, 2, 3, 4, 5, and so forth, and their opposites, negative 1, negative 2, negative 3. When we plotted them on the number line, it's a little bit easier to see what numbers are in fact integers. So what numbers are not integers? The numbers, if you look at this number line, that you would plot in between any of these numbers that we've identified and labeled on this number line. So for example, 1/2. The fraction 1/2 would be right about here on the number line. That is not an integer. Or what about 2.6, 2 6/10, right? That's just a little bit more than 2.5, but a little bit less than 3. It would probably be around here. That is not an integer. Or what about negative 1/2? Sometimes people think that because it has a negative symbol in front of it, it must be an integer. That is not true. Negative 1/2 is also not an integer because it would be between the integers 0 and negative 1. So it's in between this number line, the numbers we've identified and labeled here. So negative 1/2 is also not an integer. So let's write some of these down on your notes. The examples we just went over that are not integers are, for example, 1/2, or even negative 1/2 is not an integer. Or we said something like 2 6/10. That is not an integer because of this 6/10 part. That makes it go in between two of the integers, in between 2 and 3. And same, negative 2 6/10 is also not an integer because of this 0.6 part. So what are some numbers that are integers, but they might sort of be disguised, they don't look like an integer right when you first see them? So they're a little trickier. For example, what about 3.0? 3 and 0 tenths. Well, some people think, oh, well, there's a decimal. It must not be an integer. Not true, because what do we have after the decimal? Nothing, right? So 3.0 is the same as just 3, which is an integer, right? Same with negative 3.0 is also an integer, because if we took away, because there's nothing after the decimal. Or how about this one? If we had 10 halves, 10 over 2, we think, oh, that's a fraction. It must not be an integer. Not true. Be careful. Is this fraction simplified? No. Where over here we had negative 1/2, that was simplified, and it still remained a fraction, and if we put that into its decimal form, 1/2, we know that that would be 5/10 or 50/100, right? But what about 10 over 2? I can simplify that, right? By dividing both of these by 2. And when I do that, what do I get? 10 divided by 2 is 5. 2 divided by 2 is 1. 5 over 1. Now, you remember when we have any fraction, any number over 1, that's the same as just saying plain old 5. And 5 is an integer. So then 10 over 2 would also be an integer. It's just not simple in its simplest form. Now, what about another example? And I'll put all these should be in green, but to say that they are integers, what about 2 to the third power? Now, it's tempting to think that that's not an integer because it doesn't look like 0, 1, 2, 3, or -1, -2, -3. However, remember that this is in exponential form. So it's just a shorter way to write a longer math problem, right? When we write that in expanded form, that would be 2 times 2 times 2, which in standard form, when we calculate that out, would be 8, right? 2 times 2 is 4. 4 times 2 is 8. So in its simplest form, if you will, 2 to the third power is not simplified yet. We haven't solved the actual problem. But when we do solve it, it ends up being 8, and 8 is an integer, so 2 to the third power is also an integer. Now it's your turn to try. Go ahead and pause the video so that you can solve both of these problems on your notes first. Then when you're done with both, press play and the quiz questions will pop up. Again, a reminder, make sure after you have answered the quiz questions that you watch the video completely to the end so that you can hit submit and make sure you get credit for the video. So go ahead and press pause. So to wrap up, in today's lesson, you learned what an integer is and being able to identify where integers are on the number line, as well as some examples. So great job today. Make sure you keep your notes in your binder and bring your binder and your notes to class, and I'll see you next time. Bye-bye.